Good morning, lovely humans, or perhaps good afternoon. So today we're going to be working on section C1.3. We've talked in the past few lessons about ways to measure the center of the data and how to describe the shape. Today we're going to be focusing on something that's better than range and IQR, or interquartile range, in some situations, to be able to describe the spread of the data. So to do that, we're going to start things off. Go ahead and title this in your classwork. The date should be April 1st. The section is C1.3. We'll be doing problems 44 to 46, as well as number 49. So parts A and B should both feel like review. You're going to be making that combination histogram and box plot for each sugar. And then you're going to be finding the mean and median of both. So remember that the mean is where you add them all up and divide by, in this case, 19. There are 19 pieces of data. And then the median is going to be the middle of the data. So in this case, the 10th value. So go ahead, pause, try it, and I'll be back in a moment. All right, so welcome back. Hopefully your histogram box plot combinations ended up looking something like this. So remember, so here the first one is sugar W. Oops. And the second one is P. Notice that on the bottom, there should be the bin width of 10. And then it goes like 10 and then 20, 30, and so on. So each bin is a width of 10, and it goes from 10 to 80. So notice we have some, also the outliers, right? So we have our outliers here and here, which are denoted with, you can use an asterisk, an X, or even like just a little circle to show that there are outliers there. Notice that there are outliers also in sugar W's data display, but not for sugar P. So for the mean and median, this is part A. You can have your graphing calculator do it. It's not too hard to make on your own. That's what I did when I was doing it before this lesson. Part B asks for the mean and the median of both. So for W, the mean is 40, and the median is 40. And then for P, it's actually exactly the same. Which is super weird, right? And so the point of using this data is to show that mean and median don't give the whole story. So it's tempting to say, well, if you have the mean or median, you kind of know what's going on with the data. But in this case, that's clearly not true, because mean and median both give the same result. But when you look at the histogram, when you look at the box plot, there's clearly something different going on, right? So this one has a really tiny box, this one has a really spread out one. And so for the next problem, when you're talking about what are some of the things that are different, we would definitely say that the spread of the data is different. And then we can also say also the outliers, right? Because the first one has outliers, the second one does not. So the outliers and the center was the same, and then the shape was also different. So looking at our histogram, you can see that in this case, the shape had a very large peak in the middle, while the shape of sugar P's histogram was much more uniform. All right, so moving on to, so this was 44. Moving on to 45, we are going to be looking at the range and perhaps why it's not super useful to use as a for the spread. So let's look at, go ahead and calculate the range for both, and then I'll be back in a moment to talk about mean absolute deviation. Welcome back. So looking at our range, hopefully you got 60 micrograms in both cases. So again, what this problem is trying to tell us is the range is the same, the mean and the median are all the same. So we're trying to come up with another way to be able to describe what's happening with this data, because obviously they're two very different sets of data, and we want to be able to describe it accurately. So what's wrong with the range? Well, in this case, the range gives a really good it gives a really good depiction of what's happening at the extremes of the data. But it doesn't actually give a very good idea of the bulk. So it gives a good idea about the extremes of the data, but not a good idea of the in-between or the bulk of the data. So part B asks us to calculate something, and they describe it, and they call it the mean absolute deviation. So here we're going to be finding the distance each value is from the mean, right? In this case, 40, and then divide by 19, because there's going to be 19 distances. And then we're going to compare, all right? So looking back to our data, looking at, for example, this value of 10, how far is 10 away from our mean of 40, right? So we're going to be looking at this data. That's going to be 30 away. So the first value we'd write down is 30. And this next value, 32, how far away is that from 40? That's going to be 8. How far is this 32 from 40? That's going to be another 8. And so you can kind of get the idea. We're going to be adding up a bunch of numbers, 19 in fact, and then dividing by 19. All right, and that's going to be giving us our mean absolute deviation for W, which is going to be about 7.05. That does not look like 0.05. Micrometers, sorry. Just realized I messed up on that. Okay, and then similarly for P, you want to add up all of those distances. So now looking at P, you can see we're still using 40. So the first few numbers that you'd be adding would be like 30 plus 30 plus 25 and so on to get the mean absolute deviation for P. And so you're going to add that all up, and you should get about 16.3 micrometers. And so I do expect to see some work there. I know you can have your calculator do the work, but knowing the process is really important as well. All right, a mean absolute deviation should not be calculated if the data has outliers or is not symmetric. Why is that? So remember, if it relies on the mean, well, we didn't want to use the mean if we had outliers, if it wasn't symmetric, because the mean isn't a very good measure of the center. Okay. Moving on. So in the case that mean absolute deviation is not as good, we can also use IQR. So remember that the IQR is equal to Q3 minus Q1 in both cases. So you can calculate those. You should have already calculated them for your box plot. So Q3 minus Q1, and we're going to get 11 micrometers and 30 micrometers respectively. So that also gives us a pretty good idea of the difference, right? We can see that in both cases, the sugar P has a much higher variability. Okay. Oops, wrong one. Okay. Let's zoom out a little bit. There we go. So finally, we're going to learn about standard deviation. So you may have actually heard of standard deviation before. It's a really important concept in statistics. And we're going to calculate it by hand, which is going to feel really tedious, although Google does it pretty darn quick if you just type in like the values that you need and use some parentheses. And so for C46, basically what we're going to do is, so read the directions, try it for yourself, and then I can show you if you're still confused. Welcome back. So hopefully you can check here see if your answers match up. I will follow along as we go through. So basically this is really similar to the way that we calculated the mean absolute deviation. The difference is that every value, we're going to square it. So what it mentions in the text is that the reason that they do that is to make all the values positive. But the thing is, if we're squaring it, that's going to make the numbers weirdly large. So to get back to normal, we're going to take the square root at the end. So when you do that, you have to be careful. Like you'd want to make sure that you've got parentheses when you're putting this in your calculator, and even parentheses here if you're doing it all in one step. You can check your numbers. The top should end up 2,240 for the first one and 6,766 for the second one, leaving our standard deviation to be about 10.86 and 18.87 respectively. I don't know if that was part A or B or if that was just like 46. Doesn't really matter. Okay, and then 49, I'll be posting a link on Canvas so that you can get a good idea of how to do this on your calculator. If you don't have a calculator, it's fine. I still recommend watching the video. And just note that for 49, so you're going to watch the video, the link that I post on Canvas, and then you are going to just take note that you should get the same thing if you do it on the calculator, of course. And the only weird thing is that there is this little sigma button. So math ran out of letters in our alphabet, so they start using Greek letters. You've already heard of theta, that was used for angles. You may have heard of, you've heard of delta, that was used for like delta y, delta x. Well, this is something that you see a lot in statistics. It is a little sigma. It's kind of like a weird lopsided 6. I don't know. And so the way that you'll see it on the calculator and the way that you can notate it from the calculator is that the standard deviation, this represents standard deviation, you have a little sub x, and then you should get about 10.86 when you fill in all of your data. For the first sugar and for the second one, you would still get sigma x equals about 18.87. So just like a fun fact, how to use your calculator. It'll be helpful if you take stats next year or when you take stats in college. Thank you all. Have a wonderful rest of your night or day or morning, whatever time you watch this. See you soon.